know I did this. I did. Push and squash.
Awesome. Thank you, sir. Alrighty.
Who do you with?
I know, I saw him in the hallway. Thank you. Alright, the first thing we got to talk about is the lab write-up before I forget. Alright. So take out your lab sheet from last class. Okay. At the top you put the what? What goes at the top when you're writing your lab write-up?
Hold on, I got this.
Well,
Here, purpose.
the purpose, good. So first is the purpose. Alright, then you write a paragraph about the what?
Procedure.
Procedure. Okay, this is how I want you to write the procedure. I want you to word it such as we did, how many different tests did we do? 1, 2, 3, 4, 5. Okay, say we did 5 different tests. See the attached worksheet.
Excuse me.
So we did 5 different tests. See the attached worksheet. Because what you're going to do is you're going to staple it in. Alright, but you still need to tell me we used a meter, a ruler, and pennies, and blah, blah, blah. But somewhere within your paragraph so that you don't have to tell me how you set it up each time. Okay? Alright, and then you have
So first procedure, then materials, then the 5 different tests. And
well, first, yeah, you write the purpose out.
Then we write our materials
Yeah, you write the materials in the procedure paragraph. Remember, first you put your purpose. Take a look at this one.
what do we call this, worksheet? Or
Purpose. Yeah, worksheet is fine.
what did you call it?
I think I called it a worksheet, or I might have called it a handout, either one. All right, so purpose. Then your paragraph, and your paragraph needs to have both the procedure and the materials within it.
But I thought you said that was just me.
No, you still gotta fluff it. That's not a paragraph. But I'm saying so that you don't have to write about each test, you can just write that. But you need to still say, we set up a meter stick with rulers and a spring scale and measured the amount of pennies. Okay. All right, and then you have 3 questions on your lab sheet. If you flip over, all right, see where it says analysis? You're going to answer all of them. Remember, you don't have to type up the question, you only have to type the answer. And then you're going to staple this sheet to your lab, because I'm not going to make you do the data tables on the computer. Sometimes I'm nice.
So,
Yes, ma'am.
which ones are the questions that are going to be used?
All of them.
There's only 3.
So we have to answer. Based on your investigation, does the position of the scales affect the force placed on the walkway? You're going to look at your data and see that.
Okay.
Which is, you're going to answer everything.
Okay.
Just make sure you answer everything. That's the easiest way.
Alright.
All right? So that's our lab write-up. Not too bad, right? Pretty short. I decided to let you use the worksheet instead of making everything on the computer when it was already done for you. All right, Newton's laws. All right, law 1, with no net force, an object is at rest or traveling at a constant velocity.
Because of inertia.
Good, inertia. Now, what is acceleration when we have constant velocity? Good, acceleration is 0. Because if you're on a Sunday drive, are you accelerating? No, we're cruising.
Staying, looking at trees.
Exactly.
Thursday.
There is not. So we'll have to get that before the end of class today, okay? All right, Josh, what is Newton's second law? How do you write the formula? For the sum of all forces equals mass times acceleration.
Okay. I guess.
Good, it's that funny thing. So the sum of all forces is equal to mass times acceleration. Perfect. All right, Shelby, Newton's third law of pairs.
Is that the thing we did yesterday?
Yes, thing we did yesterday.
Okay.
So forces are always equal and opposite, right?
Yes.
So you can make up the objects that you want to use.
So it'd be like.
You're fine. Good. There you go. All right, and how would you read that, Shelby?
And it'd be the force that the second object has on the first one.
Okay, good. So the force of 2 on 1
Yeah.
equals,
The negative, you can't really tell it's a negative, but it's a negative force that 1 has on 2.
perfect. So those are our 3 laws of Newton.
Is that just a force?
We were saying when constant velocity, what is acceleration when your velocity is constant?
It's nothing.
It's nothing, exactly. All right, third law pairs. Oops, sorry.
It's all right.
All right, first let's list different types of forces. What forces can act on an object? It's from the end of last class, lecture notes. We have different types of forces. We have non-contact and contact forces, and then different types of forces.
Frictionless forces.
Okay, a friction. Friction can be a force. Okay, friction. What else could be a force? And what do we call gravity's force? It was represented with a W. What is that called?
Wait.
Good.
Oh, yeah.
Okay. Which one is always perpendicular?
Wait.
Normal.
Normal. Remember we get that from psychology? All
We
right.
actually had that today for the first time, I believe.
Oh, cool. All right. What about ropes? What kind of force goes with a rope?
Would it just be friction?
It's not friction. Friction's against the
Tension.
Good, tension. So we have tension. Do we have any more forces?
Normal. Tension.
Mhm.
Friction.
I think we got them.
Yeah.
All right. So let's go ahead and do this. All right. So let's put some forces on here. Where do you want to start? Let's start with the block. All right. And we always draw weight first. All right. So with our weight, we come. And which way does my arrow point with weight?
Down.
Down. Good. This is weight. All right. How do we draw a normal force? It's always what to the surface?
Perpendicular.
Perpendicular. Good. Now, I can't just draw it straight up and down, right? It has to be perpendicular to the surface.
So that means in the
Good. Just like this. All right.
Would that just be the opposite? Because
Well, this is our surface here. This is the surface. So if you put your pen along the surface,
yeah.
to go perpendicular, it has to be like that. All right, tension. Which way is tension going to pull? Our rope is pulling up and to the left.
So just that one.
Good. So it goes this way. This is our tension. And what about friction? Is it going to go with motion or oppose motion? Oppose motion. So if we have motion here, our friction has to be over here.
What does the V stand for?
Velocity. It's telling you that the box wants to move downwards, but we got a rope pulling it back.
Are your PowerPoints on average about 15 slides?
Sometimes they're more, sometimes they're less. It just depends on how many.
They're a bit difficult to staple when you get that.
Yeah, you really should be printing them 3 to 4 per page.
Oh.
Yeah, because that's a lot of ink to be using.
If you get still have enough room there.
All right, so So this is our next one on how do we turn it into a free body diagram. I want someone to come back up and draw the forces that we just drew on our...
My book.
Yes, you may use your book. And tell us which ones you're drawing and why you're drawing them in that direction.
Just like this. Okay.
And why did you draw it to the left?
Because that's, I'm assuming that's a rope.
Mhm.
So that's the way the rope's pulling it.
Very good.
And then... And that's the normal.
And why did you draw it that way?
Because that's the box that's sort of kind of, it's sitting there. And that's just the normal thing. It's just
But
just
normal
like-
always has to be, how is it oriented?
It's perpendicular.
Good, perpendicular to the surface, good.
And then friction. Friction this way.
All right, and remember friction is a little f.
Oh, yeah.
That way we don't get confused with it as a force. All right, good. And what's our last one?
Wait.
Wait, good. And why did you draw that one down?
Because weight also something has to do with gravity, and weight pulls down.
Actually, weight is gravity.
Very good. Yeah. Perfect. All right. So, this is if we drew our forces on this big diagram. But sometimes with diagrams it can all get very confusing, so we like to simplify. All right, and we simplify things. Okay. We simplify things on our axis, right? We don't label them. All right. Josh, I want you to go ahead and do tension, normal, and friction on our, what I call a prototype. So basically, you're just going to take these 3 arrows and put them where they should be.
Okay.
All right.
Exactly did you just draw? Is that a graph?
I just drew an axis. All right, so the first thing you got to ask yourself is, which force goes straight up and down, or straight up? What's our up force? Good, normal. All right, which one's to the left? And which one is to the right? Perfect. All right, so those 3 were easy, right? But if you look at how they're oriented, so do you see that I just took this and turned it a little to equal that? So where would weight go? Can weight be straight down?
I guess not in that case.
Because look, is weight, is this line perfect?
No.
No, so it
Well,
can't
this
be
is-
our down. All right,
Would it be?
it would be a slant line. I think Shelby's gonna come up. Shelby's excited. All right, now we gotta figure out which way it goes. So remember, what you've done is you turned your head this way to look at it, and now you've turned it upwards. So where does this arrow point?
Slanted.
Which way? It is slant down.
What is it already for that?
You gotta tell me.
Ooh! It's not that way.
We're good, all right. Which way? It is that way. Go ahead and draw it for us.
Okay. That way.
Yes. And that is weight. Now, let's see, do we see why it's that way?
Weight
Yeah,
is
because
the
originally it was like that, but then you turned it that way. So it's like this, but then you turned it that way. So wait.
Okay, because if I took this and I turned it a little, I wish I could turn these. Wouldn't that be fabulous if the board did that? If I could turn this, wouldn't weight be right at the bottom like it is here? Okay, good. So that is how we draw these. Now these will be the most complex we'll ever do, where you have to turn your head. Now, here's where it gets fancy. All right, so this is perpendicular, right? Yeah. This is a nice horizontal line.
Yeah.
Then we got this. And this has a, what kind of component is that? Which one's the up and down component? Y or X?
Y.
Y. So it's going to have a Y component.
Could you move a little this one?
Yes.
Thank you.
It's going to have a y component and what other component?
An X.
An x component. Fun. So it brings us back to where we talk about having to break things down in components. But y'all are already great with that, right? Yeah. All right, so I'm going to give you on the next slide 4 steps on how to always complete these.
Always. Never with exceptions.
Never with exceptions. It's always the way to do them.
Okay. What?
She was just looking at the camera. To the back side anyway.
Yeah.
Alright, so step 1 is make a prototype. And what I mean by prototype is, remember when I just threw these lines on here?
Yes.
That's a prototype. That was my, proto means original or first. So that was just my rough sketch. So make a prototype. You won't always have to, but they're good to do when you have inclined planes. Alright, the second one is determine net force. And Shelby, what is the equation for net force?
Summation F equals MA.
Good. So we have to determine our net force. Alright, then we have to draw our forces. And what force do we always start with? What's the one that always pulls us down?
Weight.
Good. Start with weight. And Josh, what is the equation for weight? Weight equals?
Negative. Geez, it's slipping my brain.
What is your weight?
So what's the gravity pressing down
On your what?
on mass?
Good. Mass times gravity.
Is that simple?
That's that simple. Step 4 is to add up all your forces, and they have to equal step 2. So are we ready to give it a try? All right. All right. Block 1 weighs 1.5 kilograms and is resting on a surface. A hand pushes down on the block with a force of 20 newtons. Draw the free body diagram and determine the normal force of the surface on 1. So the normal force pushing up.
Is this reasonable?
All right. Do you
Is
want to?
this actually physically reasonable?
Yes.
Can I write up something?
Do you want to write, you mean in your notebook first or on the board?
I don't know.
You want to go on the board?
Yes.
All right. All right, so what is step 1?
Determine. No, make a prototype.
Good. So do a rough sketch. Just a little rough sketch of what's going on.
So surface.
All right.
Block 1.
All right, but how much mass does it have? That's normally what we put inside the block, just to help us.
5.
Good. 1.5. All right. You don't have to put the kgs. We know it. All right. So you got the block on the surface. Now we need a hand pushing down.
Do I have to draw the hand? Okay, anyways.
That's good. All right. And tell us how that hand is pushing down. All right, very good. All right, what's step 2?
Determine the net force.
All right. So what's our equation for that? All right, now it says that this block is at rest, Josh. So what is the acceleration at rest? if you're not moving? What's your acceleration?
There's no acceleration, there's
Good.
no velocity.
So if there's no acceleration, what do your net force equal?
0.
Very good, Josh.
Yeah.
All right, so you can tell us that net force equals 0.
So it'd be
That? Perfect.
Alright.
All right,
And
what's
then
step 3?
draw forces starting with weight.
Good.
So it'd be
All right.
that.
Okay, so weight equals mg. All right, so what's the weight of your block?
1.5.
Good. Times.
Oh, times.
Well, 1.5 is the mass, right?
Oh,
You gotta determine the weight.
I knew that.
And gravity is always what?
10.
Negative 10. All right, so what's your weight?
Would it be 0.15? No, it'd be 15.
What type of 15?
Positive. Negative. It's a negative because that's negative.
Very good.
So weight equals negative, what did I just say, 15.
Good. All right.
Okay, no.
So now we got to get our free body diagram done. All right, so let's talk about our forces. All right, I guess we need some more room. I don't know how to make a blank slide. Let me look
I
real
can
quick.
rewrite that.
No, it's fine. Here, let me see.
I can write it there.
Okay, yeah, that's fine.
Yeah. Okay.
All right, and if you want, you can practice on the prototype first.
There.
Okay, so draw your weight one first. You said weight was negative 15, and that's what?
So it'd be
Okay, negative 15, good. Now, you also have another downward arrow, don't you?
That's the force.
The force of the hand.
Yeah.
So we have that force pushing down.
Uh-huh.
So that 20 newtons, since it's pushing down, Josh, what should be the sign in front of the 20 if it's down?
Negative.
Negative. So now we have a negative 20. Put a negative in front of it. All right. So if we go up to the...
Not like how the pins in the way. Okay.
All right. So we have negative 15. All right, going down. We have a negative 20 going down.
Do you have to add them?
We draw two separate arrows on our free body diagram. So go ahead and draw one for weight, and then one just beside it for...
Wait, would that have to be over there since it's a negative?
It doesn't matter. It's just because it's going down.
And then that one for force.
All right, so 1 equals what?
Would that have to be
Okay,
would that be right?
yeah, but we actually put the number straight in.
Oh.
Okay. And what I like to do is I like to draw weight coming straight down, and then just go beside it for your
Oh.
next one.
Okay, that works.
All right, so put the numbers beside them.
So negative 15.
Good.